It brings me great joy to introduce to you Dr. Michael Eldred, who's coming to us live from Cologne in Germany. Dr. Eldred is a mathematician, a physics guru, and took a right-angle turn as a young man into the field of philosophy. And he was with University of Sydney for many years. And today he's going to be presenting the underpinnings here of a philosophical reflection on what the cyber world is. Welcome, Michael Eldred.
Thank you, Katina, for the introduction, and hello to everybody. I'm very pleased to be able to speak to you here. I want to do just a quick run through a few points, and I'll start with the very important philosophical distinction, just to mention it, between a priori knowledge and a posteriori knowledge. I'd say a posteriori knowledge could be translated these days as what you call evidence-based knowledge. And evidence-based knowledge is a posteriori in the sense that it comes after the fact. You have to be given the experiences in the empirical world. These days, these experiences are given by data of various kinds, so you have to collect data. So all this knowledge is then built up on the basis of what you gather and model from what is given by experience. But on the other hand, you also have a priori knowledge, which is very famous, not just with Immanuel Kant, but it has a general applicability. It relates to what you know from the elementary phenomena before you go out and experience particular experiences in the world, start gathering data. So this kind of knowledge is before the fact, whereas a posteriori knowledge is after the fact. And the hallmark of the empiricist knowledge with which we live today, both in natural science and in social science, is basically a posteriori knowledge, evidence-based. The open questions and the tough questions relate to how are the elementary phenomena already conceived before you actually get to facts? How are the elementary phenomena grasped as such? And I want to illustrate that in connection with the topic today, which is AI and cybersecurity. So I'd like to say how is the cyber world to be conceived a priori, not just on the basis of facts. And I'd point to a very famous article by Alan Turing from 1936 on the theory of computable numbers and the so-called Entscheidungsproblem in mathematical logic. So this is a mathematical paper, but it can be regarded as also containing the germ of what then became computer science, computers, and eventually it turned into the internet with interconnected, interneted computers worldwide. And we're living in a world which goes back to its elementary unit, which you can find already in Alan Turing's famous paper from 1936, where he develops the idea of the universal Turing machine. And even if you study computer science, you'll learn that anything that a computer can do, right up to the supercomputers we have today, can be done in principle by a Turing machine. A Turing machine is a very dumb computer. It's very simple. I won't go into the details of that, but very briefly, what a Turing machine does is it is loaded with a bit string, digital bits. One bit string is the algorithm, and this algorithm works on step by step, goes through data bit string, which is fed into it. And from this step-by-step procedure of the Turing machine, it produces an output, which is another bit string. So you can say the cyberworld is inhabited by lots and lots and lots of, millions and billions and trillions of universal Turing machines, where the algorithms are copulating with the data bit strings, producing output, and these output bit strings are there to control movement or some change. And this change can be within the cyber world. It could just be changing something in the what is circulating in the cyber world, or it can be used to control things in the physical world, say the water supply of a city or a power plant or whatever. So you have the cyber world consisting of these bit strings in interplay with one another, and they control the movement of change of some kind. And what these algorithms do, the algorithms first of all have to be written by a programmer, and the algorithm is a codification, a digital code of some understanding of some practical thing that has to be done in the world, whether it's the production of an image on the screen, or maybe switching a smartphone on and off, or a video camera on and off, whatever it is. Lots and lots of different applications which have to be understood in some way and then codified, and then the code is put into the cyber world where it does its business automatically. Now, one of the really interesting things about these universal Turing machines is that the algorithmic part, the operative acting part in the copulation of the bit strings, the algorithm can be infiltrated by another bit string, which is insinuated into that bit string, and this is what we call a computer virus. And if an algorithm is infected in that way by a bit string, that means that the action or the movement, which is controlled by the algorithm, changes. And that is the principle on which you then have the problem of cybersecurity. Cybersecurity is a problem of algorithmic bit strings being infiltrated by nefarious bit strings.
1 minute, Michael.
Yeah. Sorry?
1 minute.
Oh. So these bit strings, the cyber world intermeshes with the movement of what I call thingified value. You can think of thingified value as anything that has a price. And this is the way our economy is organized globally as the movement of thingified value, which is on its way to attempting to augment. This is the intermeshing of the algorithms with the ratified value means that we have applications such as supply chain management, logistics, accounting, market information, and so on. So this thingified value itself is a social power that controls movement in the world. It also controls what can happen in politics. You know that lobbying is mediated by the medium of thingified value. And all of us, by living in this cyber world, which intermatches with the what I call the gainful gain, means that we are all captive to this medium of association with which we have to do with one another. And the algorithms in this interlocking with the gainful gain means that we are controlled in our everyday lives by, and increasingly so, by what the algorithms say we can and cannot do. I think my time is up.
Thank you so much, Michael Eldred, pointing to control, thingified value, the interplay, the movements, and these injections of bit streams towards computer viruses. What an awesome grounding for our philosophy and our philosophical reflections for the whole day.